Hello, Algebra 2, and we're recording. How's it going? I did not have a 10.3 video, but I don't know about you, but I feel like vertical shifts, which was the topic, isn't that difficult. I hope I'm not offending anyone, but I just truly don't think it's too difficult that when you add a number out in front, it will move it up. And when you subtract that number, it will move it down. That's about it, right? So I have created a slider for every single value that could be changed. And you'll notice that this h value has been introduced. So the a value affects our amplitude. I'm not going to explain that again. The b value affects our period. It scrunches it in. The k value shifts it left or right. But now finally, we're seeing a horizontal shift. Okay? We are seeing a horizontal shift. All right? So let's get into the nitty-gritty and kind of look at how it moves. So let's put everything at 1. So there's no change in amplitude. And b is 1. There's no change in period. And we're not even going to move up or down. So k is 0. We're only going to look at this h value. We know that sine naturally starts at 0 and continues on its merry way. Okay? When we subtract, let's say, pi, take a look. The start, if you will, has moved over to the right pi. Because we've seen this time and time again, when you subtract in parentheses, it will move it to the right. And when you add in parentheses, it will move it to the left. Okay? So it's kind of hard to see the movement. I'm not going to lie, because it's repetitive, right? But give me a moment. I'm going to pause. Okay, I set something up real quick. I've labeled the that starting point, and as I move it to the right, that's kind of what I want you to focus your eyes on, right? Everything is moving to the right, but we want to have like a foundational point to like stare at and to find, right? We need a point of reference, okay? And I'm using that point as a point of reference. So when I move it to the right pi, you can see how that point is now at pi. Or if I move it to the right pi over 2, you can see how that point is now at pi over 2. The whole function is shifting, right? But it's good to have a point of reference there, okay? So yeah, that's how that happens. And I can move it to the left, negative pi over 2. Okay? Now, there's something interesting that happens, right? If you move it a certain amount, it almost looks like it didn't move. Watch. If I make h 0, I don't move it left or right. There it is. But if I make h 2 pi, did it move? Right? Did it move? Here's 0. Here's 2 pi. Here's 0. And then here's 2 pi. Right? The function looks like it's in the exact same spot. And that's because we're shifting it, that all of a sudden it overlaps with itself. You'll notice my blue point moved, right? Yes, it moved to the right, 2 pi, but it shifted and just fell right back into the same spot because of the repetitiveness, right? Fascinating how that works. Use Desmos as much as possible, right? There's no point in like torturing yourself and graphing everything meticulously by hand. But I would like you to realize what each thing does. When I give you this equation, let me pause it so it doesn't last forever to type. When I give you an equation like this, I really need you to at least be able to read it. Do I need you to graph it perfectly? No. Desmos graphs things perfectly. You are not a robot. I don't need you to graph it perfectly. That's not what I'm asking for. But I would like you to understand what is going to occur. You should look at this and go, oh, I'm going to flip. I'm going to have an amplitude of 2. I'm going to move right, pi over 2. I'm going to move down 2. And this 3 changes my period, right? I need you to know those things. Do I need you to be able to plot it perfectly? Do I need you to be able to just instantly plot it? No, but I need you to be able to read it. The negative flips, the A value changes the amplitude, the B value changes the period. This value in parentheses moves it left or right, and this value on the outside moves it up or down. I need you to know that, okay? Now, if I were to plot this by hand, right, I know that, like, when I take a look at this, right, look, the amplitude is 2. I know that much. And look, the middle of the function is at negative 2. But cosine, if I get rid of this minus pi over 2, usually starts at the min when it's flipped, right? If I get rid of the flip, it starts at its max. But when it's flipped, it starts at its min, right? On the 0 point. But watch how it moves. Watch how it moves to the right. This point right here is going to move to the right a little bit. Minus pi over 2. Right here. I got confused for a second. Right here at pi over 2. Because this point was here. Right? And now it moved over. See how the function has been shifted? It's hard to see it like super concretely. I would agree. It's hard to see it. But that's what the slider's for. Yeah? That's what the slider's for. I can see it moving left or right. And this point, give me a sec. This point is what's doing the sliding. Yeah? It's a good point of reference. When I'm not moving left or right, when B is 0, boom. But then it's a good little point of reference. Okay? Okay. I'm going to pause again, get myself set up on the notes. Okay, so taking a look at these problems, it says graph, graph, graph. I don't need you to be able to graph them by hand. I just don't care. I just don't care. I don't want you to. But I want you to be able to read off what's happening. So let's just describe what's happening. What is this telling us to do? To go right pi over 2. That's it, right? Because the negative tells us to go right and a positive tells us to go left. Okay, great description. What is this telling us to do? Go right 3 pi over 4. Lovely. That's all it's telling us to do. I need you to know that. I need you to know that. Okay? And what is this telling us to do? Go left pi and up 1. I need you to know that. I need you to be able to read that off and to describe that. Okay? Okay, I got something set up for us here. I am going to graph one by hand just to show you the process. I've already got some done out here. Here is the regular sine function. It starts at 0 and ends over here at 2 pi. What's going to happen? If we're moving right 3 pi over 4, that means each point is going to move over 1, 2, 3. So it started at 0 and it got shifted to 3 pi over 4. And this point's going to go over 1, 2, 3 points over here. Yeah? And then this point right here will go over 1, 2, 3 to here. And this point will go over 1, 2, 3 to here. And this point will go over 1, 2, 3 to here. Yeah? You see that? How that works out? So now, because it shifted, right, it's going over. You see that? It's shifting over pi over 4, 2 pi over 4, 3 pi over 4. You see that beautiful? You see that? It's kind of cool, right? That's the shift that is occurring when we subtract the 3 pi over 4. If you can't give me credit for that, you need to lighten up, okay? You know that's beautiful. You know that's beautiful, okay? So I hope that's giving you an understanding as to how this is shifting. And the same thing could happen if it was moving to the left, right? That's what's happening. Okay. I know this one has more going on, but I don't care. I'm going to ask a question here. Tell me everything that's happening here, okay? There will be some options that pop on screen now. Okay, so you told me everything that's happening. The amplitude got changed to 3. The period here got changed to what? Remember, it's 2 pi over b's. The 2's canceled, so the period is pi. What did this do? It moved us right. Pi over 4. What does this do? It moved us up 1. Okay? This moving, this is actually a word, it's 10 minutes into the video and I haven't even used the word. Technically speaking, the horizontal shift left or right is called a phase shift. Don't ask me why they decided to give it a special name for trigonometry. I hate it as much as you do. I even catch myself calling it a horizontal shift. I mean, that's basically all it is, right? But technically it is a phase shift, okay? So boom, 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 boom. There it is. Do it again. One more time for me. Tell me everything that's happening. And some answers pop up on screen. So you told me everything that's happening. That negative flips it. That 2 makes the amplitude 2. Okay? That pi over 2, that's kind of weird. That is the b value. 2 pi over 2. What happens when you divide by a fraction? You multiply by the reciprocal. Cancel, cancel. And we end up with 4. How about that? This is moving us to the right 1. And this is moving us, I should use phase shift. Right 1. And then we moved down 5. Okay. Enough of that, right? I think that's enough of that. I think you can read that stuff out. I have a lot of confidence in you. I think you can read that. I think you can describe it. Are you going to be pros at graphing? No. Am I a pro at graphing? No. No one needs to be. That's what graphing calculators are for. Like literally, no one needs to be good at graphing by hand. You should be decent. You should have a general idea, but nobody needs to be like super accurate. All right, last set of problems. We are looking at the graphs and coming up with the details. We're looking at the graphs and coming up with the details. So let's look at, well, okay, whatever. Let's just start with the first one. What do we got going on here? So this is the cosine function. One second. Okay. This is the cosine function. So what do we got here? We have an amplitude of 1. That's pretty obvious, right? You draw a line down the middle. This function is 1 unit tall. Our amplitude is 1. Okay, let's erase those details. I don't want too many distractions. What is our period? It is starting here and going like so. So the length of this period is 2 pi. Now, did this thing move left or right? You know what? Let's pause on that for a moment. Here's the middle of the function. How far did it move? 1, 2, 3 down. So a vertical shift of down 3. Now, here's the thing with these functions. And we're 14 minutes into the video, and I'm not trying to make this too terribly long. Here's the thing. Like, did it move? Did it not? Because cosine starts at its max like this, right? It goes exactly like this. Exactly what this did. It just shifted down. So, technically speaking, there really wasn't. Or was there, right? Like, had I shifted 2 pi, I would end up in the same spot, right? I want you to remember that. I mentioned that earlier. When you shift, right, by a certain amount, the function just looks the same. Here, I'm not shifting at all, and then here I shift 2 pi. Did the function really move? No, not really. It's in the exact same spot. 2 pi, 0. 2 pi, 0. It's not moving because when you shift it so far, it just ends up in the same spot. So technically, no, there was no phase shift. Let's do it again. This is sine. This is sine. What is the amplitude? How much time we have? 15 minutes. Okay, the amplitude is 1. The period, where is it starting? If you see what I'm saying here, sine starts in the center, right? Sine starts in the center. So this is sort of the starting point, right? It should have been here, right? I know you might not be seeing what I'm saying. How does sine usually look? It looks like this. Okay, something like that. Well, now it's been shifted. Actually, here, give me another second. Hold on. How does sine usually look? It looks like this. Okay? It looks like that. And what has this done? This has shifted up and then gone to the right. And now it clicks into place. This is usually what sine looks like. But it shifted up and to the right, and then it clicked into place. You see what I hope that's making it clear. So the period here is starting at pi over 2 and ending at 5 pi over 2. 5 pi over 2 minus pi over 2 is 4 pi over 2, which is 2 pi. Our period is 2 pi long. That's the distance between these 2 points. Our phase shift, it moved to the right, pi over 2. Our vertical shift, it moved up 1 because there's that line down the middle. And therefore, our equation looks something like y equals sine of pi over of x. It moved to the right, so minus pi over 2 plus 1. Okay, one more and I ask you some questions. How about I ask like several questions in a row so you're not having to like choose really long questions. So here's a question about the amplitude. And here's a question about the period. And here's a question about the phase shift. And here's a question about the vertical shift. Now you might have had to pause and stare at the function for a little bit, but I really hope you gave it a shot. And this is sine. So sine, generally speaking, right, starts in the middle and goes da, 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 like this, right? So here's the function. Right? That's what sine usually looks like. Okay, but now it's been shifted up and to the right. Or did it move to the left? It doesn't matter, right? It moved up for sure. Did it move to the left? Did it move to the right? I don't know. It doesn't matter. There's multiple correct answers, okay? So what have we done here? We moved up 1, 2, 3 is our vertical shift. And our amplitude is obviously 1. Our period, I'll worry about in a second. We moved to the right. I'm going to call that, I don't know, what do you call that? 2/3 maybe? It moved to the right 2/3. And our our period, is how long? Starting here and ending here. It looks just like 1, basically, right? It's actually better to look at the tops. Like, how far are the tops apart? 1. Right? See that? So the period's 1. Now, to write the, how do you make a period 1? That means the b value is 2 pi. Because when you do 2 pi divided by 2 pi, you get 1. So y equals, our amplitude's 1, so it doesn't matter. Sine of 2 pi times x. We moved to the right 2/3, I guess it looked like. and then plus 3. Clearly, this is not an exact science, right? Like, we're just making some casual observations. Trust me when I say this, the answer choices on the assignment will be obvious if you know what you're looking at. There are no tricks up my sleeve. I want you to have confidence with this, and if you're at this point watching this video, I say it every time, but I appreciate your time. I thank you for watching and to getting to this point, and I look forward to seeing you in class. Okay? Have a lovely day, evening, morning, whatever.